All right, so in this video I want to talk about partial fraction decomposition. How does it work? What are the rules? When can you do it? When is it helpful? And so the first thing that I want to do is I just want to talk about a partial fraction decomposition is taking, I kind of think of it as undoing addition or subtraction of fractions with polynomials in them. And then in that way what you get is you go from something that's more complicated to something that's written as a sum of simpler fractions. And the point here is that the left side is hard to integrate, at least right away, but the right side is easy to integrate because we know how to integrate 1 over these types of quantities, right? So if we integrate, as we said in class, 1 over ax plus b, so that should be an ax plus b. What we get is 1 over a times the natural log of ax plus b, plus a constant. Okay, but whatever. So we got 1 over a natural log of the absolute value, ax plus b. The absolute values will be important here. Okay, and we'll see some places where that'll matter. So this is a partial fraction decomposition. Remember that you can only do that when the degree of the numerator is strictly less than the degree of the denominator. So in this case, we have a first degree term in the numerator, a second degree term in the denominator, because you have an x times x, so you get an x squared there. And it turns out when you have linear terms in the denominator, so your first step in partial fraction decomposition is always factoring the denominator. And in this case, it's already factored. And we have linear terms, meaning that they're to the first power. Okay? And so when you have linear terms, the partial fraction decomposition part that you get is just a constant over that linear term. That's the end of the story. Okay? And so there's not really too much there. I'm not going to find a and b. I'm more interested in talking about how partial fraction decomposition works and when we can do it. And so if you were to have something like 3x squared plus 4x plus 1 all over x times x minus 2 times x plus 5, you would just get a partial fraction decomposition in the shape of a over x plus b over x minus 2 plus c over x plus 5. And that's it. Okay, that's all you have to worry about. The only complications are when you have nonlinear terms in the denominator. So for example, if you were to have something like x minus 2 squared times x plus 4, the x plus 4 bit is easy. The x minus 2 part, what you need is you need actually to have an x minus 2 in the denominator and then an x minus 2 squared. Okay, so you could have b and c. So because you have a second degree in the denominator, a term of multiplicity 2 is the way what I really want to say. Multiplicity meaning the power that you get when you factor it. Since we have a term of multiplicity 2, we're going to have two corresponding terms in the partial fraction decomposition. So for example, if you were to have x plus 4 over x minus 1 cubed times x plus 7 squared, then your partial fraction decomposition would have an x minus 1 squared, x minus 1 cubed, and then also an x plus 7 and an x plus 7 squared term. And we'd have 5 constants, a, b, c, d, and e. Okay, and then we could find the 5 constants algebraically using the methods that we've talked about. I'm more worried about figuring out the shape of this for now. And then the last case to talk about is if you were to have something like 4x squared plus 1 over, let's say x squared plus 9 times x minus 4 cubed. What you have to do differently here is for the x squared plus 9 term, you have a second degree polynomial in the denominator, so you need a general linear term up top. So you need both a constant and an x term in the top. And then the x minus 4 term works the same way that we've been talking about. So you have an x minus 4 squared, and x minus 4 cubed. C, D, and E. And so that would be the shape of your partial fraction decomposition. When I say shape, I mean that's the general form of the partial fraction decomposition. Okay, and that's really all I wanted to do in this video is to talk about the different scenarios. You can look up in the book what happens when you have something like x squared plus 9 quantity squared. It's going to work probably the way you think it is. I guess let me just do one more example here. Let's say I were to have 5x plus 7 over x squared plus 4 squared times x minus 2. So the x minus 2 bit, you know, is just going to be a over x minus 2. And then for the x squared plus 4 part, you're going to have x squared plus 4 and x squared plus 4 squared. Each term there will have its own linear term up top. So you'd have a bx plus c and a dx plus e, and that is it. Okay, that's the really like 90% of the material in this section is figuring out how these partial fraction decompositions work. I will do another video where we actually go and find these constants a, b, c, d, and e in some examples, and then I'll do more videos where we do integrals, which is really the application for partial fraction decompositions. But that's it for now.